Namaste everyone, welcome to the course Image Processing using Python. I am Dr. Atul Kumar Dwivedi, Assistant Professor, Bundelkhand Institute of Engineering and Technology, Jhansi. This tutorial is in continuation of previous session, therefore it is recommended to all of you to watch the previous session before continuing to this tutorial. Before going further, let us discuss a short outline of this tutorial, this session. In this session, I will discuss about feature extraction techniques in images using Python. These will include the basic features, then edge detection feature, then transform based feature and all. Features is very simple term. For a person, if you think about the features of a person, then you can say that how he looks, what is his height, what is his weight, etc. Generally these things are considered as features. Extracting features from an image means keeping only important features for identification. If you want to buy a car, then you go to the showroom of the car. Then what you will do first? You will decide the budget. Then you will decide the features of the car, the facilities of the car, like what is the AC, what is the capacity of the air conditioner system, how the music system is, what is the quality of music, airbags are there or not, what is the protection system of the car, how speed controls, what are the speed control systems, it is electric, it is based on CNG or petrol. There are many things in the that all need to be decided. So these things are the features of the car. The specifications, in the technical term we say specifications, but for the image processing terms we say the features. So features are the basic attributes or aspects which clearly help us to identify a particular object or image or anything. Features are the marked properties which are unique. You can ask me why we need features, what is the role of these features, where features are used. The simple answer to all these is while working on an image data set, we are not going to see every image and identify the objects. We give it to the computer program that you understand about the objects available in the image. If you have 1000, 5000, 10,000 images database, then the computer will do the things. Therefore, the machine should understand the features of images so that the machine can segregate the images, machine can cluster the images, machine can classify the images based on the features, based on the aspects, based on the qualities or specifications of the image. Image processing starts with a database, annotated database. Then you do the first pre-processing of the data, like applying the filters, removing the noise and all things, edge detection, etc. Then the second step is feature extraction, and then we go for the classifier testing, then the classifier training, then testing. In this way the image processing or working on the database works. So in this process, feature extraction is most crucial work, that is most important work of the image processing. There is no exact definition of the features of an image, but basic things of the image like pixel values of the image, number of rows in the image, number of columns in the image, gradient of the pixels, etc. can be considered as a feature of the image. There are some advanced level features of the image also, like mean of the image, median, skewness, kurtosis, Fourier transform, wavelet transform, edges of the image, etc. etc. Extracting these features from the image can be done using different techniques in Python. The feature extraction in Python, if you want to write codes in the Python, then the first thing you have to decide the IDE on which environment you want to work on Python, and then if you have because I personally use Google Colab, If you are using Google Colab, then you have to go to the Colab, then you have to give open a new, go to the file, then open a new notebook, then in the new notebook you have to click on the plus code button displayed just below the file tab of the new notebook, and then load all the libraries required for your application. Usually required the libraries for the application are NumPy, Matplotlib, skimage, OpenCV, etc., etc. Now after doing all this, as for extracting the features of image, we need to access the image also. Image will be required for which features, therefore we have to mount the Google Drive. To do how to do this all things, that all I have already discussed in the previous video, and you can watch the previous video, or you can go, if you have not seen the video, you can go there and watch again. Here is a I am giving again a short description of the how to import the dependencies libraries in the Python, like importing NumPy as NP, pandas and PD, CV2 as CV, skimage I will call SK, like that. To mount the Google Drive, you have to write a command from google.colab import drive, then drive.mount / content.drive. Now there are although I have told you that there are many features of an image, but we will focus on some features in this tutorial, and our discussion will be limited to the pixel features basically. Then I will discuss about histogram based features, then some statistical features, then edge detection based feature, then transform domain based features, and at last I will tell you how features are determined in machine learning and deep learning techniques. Let us start with the first basic, that is pixel based features. The simplest method of feature extraction is to use all the grayscale value of the pixels. Read the image using the imread command of the OpenCV library, then you can see the image that is really visible in your notebook, and then you convert to the grayscale. So either you can write your own function to the grayscale, or you can use any one plane R, G or B, that all are in grayscale. Single plane is in grayscale, and but when they are combined together, then that becomes a color image. Here I am using one equation, that this equation is similar to the RGB to gray command available in MATLAB. So therefore I have used this coefficient multiplier 0.2989 R to the R, and 0.5870 to the G, and 0.1140 to B, and after this multiplication a single value of gray will return, and this value can be used as a grayscale image. So using this conversion function to the grayscale image, there are many other ways for converting color image to grayscale. You can use the standard function available in the library, or you can directly sum up R, G and B without using coefficient multiplier. You can use some different coefficient multiplier also, there is no problem, but actually you should get a good output, good grayscale image, that is our target. Also by using the methods we can separate R, G and B. You can understand how to separate R, G and B from this function. In this function that is written here for RGB to gray. So this process is actually computationally quite expensive, but we can do it. RGB to gray conversion, you can plot the converted image, and then what you can do, you can separate every plane R, G and B. You can also plot the separate every plane. You will see that grayscale images are coming out. Why they are grayscale? Because they are one dimensional. They are means there is no multiple copies like pages in the image. Therefore they are coming as a grayscale image. So how to convert it to the feature? This is a square matrix, but for a feature of one image you have to convert it into a single array. So to convert it into the single array, we can use the reshape command available in NumPy. So for reshape, you can use np.reshape, then you have to give the size of the image. So whatever size you can get from the image.shape command, that size has to be given here. Then similar to this, you can reshape colored image also by giving the dimension up to 3, means multiplying the number of rows and number of columns and then to 3. You can see the results in the Google Colab. In left side there is a place where you can, if you click there, then you can see the size of variables. That is also one advantage while using Google Colab, that we can see the variables. Although whenever you open that, it will show that it will slow down the process of computation, but we are not doing a big computation, we are doing just some simple feature calculation. Therefore you can see the number of variables. Now let us go to the second one, that is histogram related features. We know that the images are stored in as a pixel values, and each pixel value represent color intensity value. So what is histogram? Actually, histograms are the distribution frequency distribution of these intensity values that occur in the image. For example, if I have 10 values, just for example, images have many values, many pixels. For example, if I have only 10 values, or out of these values 1 to 7 are coming only once, means 1, 2, 3, 4, 5, 6 and 7. Then 8th number value is 8 itself, 9th number value is also 8, 10th number value is also 8. That means 8 is repeated 3 times. Then its histogram will look like the image shown in the figure below. That means we will see that the numbers 1, 2, 3, 4 are coming as 1, and at 8 suddenly there is higher peak of 3, and then 9, 10 are 0. Now let us consider a real image that have many pixels, then apply the histogram command and see the results. The command is available in the matplotlib library. Therefore we can use simply plt.hist, then take the image, and then number of bins also you have to give, that in what range you want to see the result, and then plt.c. You can see there many values are, means at some place there is a peak and some place there are lower. So you can see that what value is having highest repetition inside the image. Also you can see what values are having lowest repetition in the image. This kind of conclusions can be made by using histogram. Now the question is, how can we use image histogram as a feature of the image? So because here as a result all values are coming, so the solution to use as a histogram as a feature, either you can convert it to a single row, or you can take the peak values of the histogram. That way you can get the feature of the histogram. So to get the peak values are also called center of the histogram. So there is a command in the histogram of sk image library. So you can import the histogram from sk image library. If you take that, then you can get centers also directly. So in that second argument, as a second argument of the output, you can give hist centers. These histogram, so here we get two things as a feature. Either you can use the complete histogram as a feature of the image, or you can use histogram centers also as a feature of the image. You can see the results of the center. For the centers you will see only a single curved line that is going through the peaks of the image. The values of this will be the same, means you can get an idea that how many values are of 200 repeated. Here in this case mostly values of 200 are repeated 6000 times in the image, and the value there are very less values at 255. That means bright color means white color is in the less area of the image, and also 0 is also very less. So there is no black portion, complete black portions is also very less in the image. Now let us go to statistical features. These are the mostly used features of the image, and also there are wide variety of statistical features. First feature of statistics is the mean value. So mean value can be mean of the pixel values of complete image. So single value will come as a output. Mean can be the mean value of the rows of the image. So in that way the features will come as number of columns, and you can reshape and you can make them in a single row. Now you can take mean of the columns also. When you take mean of the column, automatically one row will come which will be equal to number of columns, which size of the row will be equal to number of columns. In this way different kind of means can be used as a feature. Mean can also be from a color image. A mean can be mean of a pixel can be from R, G and B separately. If you have a color image which have 3 planes, R plane, G plane and B plane, and then you can take all these planes as a mean 1 1 1 from 1 pixel. Suppose 1 1 pixel is taken, so all or 0 0 for Python, for 0 0 pixel is taken. So for first pixel for R 0 0 and then G 0 0 and then B 0 0, we can take the average value that will come out as a mean. So this way. Similarly median can also be for the complete image, median of the complete image, then median of the rows, then median of the columns, then median of RGB, and then similarly mode also. So mode can also be calculated for rows, mode of columns, mode for complete image and mode for RGB. Centroid is also important feature of the image. Centroid can be centroid is not mean value. Centroid is something calculated for every pixel from the neighborhood pixels. Also we can take maximum value of the rows, we can take minimum value of the rows, we can take average value of the rows, we can take the maximum value of the columns as a feature, we can also take minimum value of the column as a feature, we can take the average value of the columns as a feature, and the important features for statistical features are variance, standard deviation, kurtosis and skewness. I will take these 4 features in detail. So let us start with the variance and standard deviation. Variance and standard deviation both come together or are similar term. Many people get confused about it. Therefore, I am explaining here the difference between these two. Actually, the standard deviation is the spread of group of numbers or pixels from the mean. It is the measurement of spread of all pixels from the mean, whereas variance measures the average degree to which each pixel differs from the mean value of the image. Understand that deviation refers to a group, whereas the variance refers to each individual pixel. So the deviation, standard deviation is the square root of variance. Variance is the average of all data points within a group. Skewness is important, very important feature, and many research papers have used skewness in their work. Skewness is the measurement of statistical that describes how symmetric or asymmetric a probability distribution is. Asymmetric distribution is one that has same shape on both sides of the mean, such as a normal distribution, whereas asymmetric distribution is one that has more values in one side of the mean and other side is not, there are not so many values. So for example, log type of normal distribution, that is asymmetric distribution. Skewness can be calculated using the formula mu 3 upon sigma to the power 3, where mu 3 is the third central moment and sigma is the standard deviation of the distribution. There are different type of skewness in the data, in the image, depending on whether the distribution has more values on left side of the mean or right side of the mean. The types of skewness are zero skewness, positive skewness and negative skewness. Zero skewness means the distribution is symmetric and that has no skewness. The mean, median and mode are equal. In this case, mean, median and mode, all three values will come equal. Whereas positive skewness is in which the distribution is right skewed or right tailed, means it has more values on the right side of the mean than the left. The mean is greater than the median, which is greater than the mode. Now come to negative skewness. This means the distribution is left skewed, left sided, meaning that it has more values on the left side of the mean than the right side. The mean is less than the median, which is less than the mode. Now another feature of the image, kurtosis, very popular among the researchers and the image processing experts. Kurtosis name is a statistical, it is also a statistical tool or a statistical measurement. This describes the shape of the probability distribution. It is based on the probability. Especially thickness of the tail is important in case of kurtosis. Tails of the distribution are the part of the distribution that extend far from the mean, and they indicate how often the extreme values, outliers, are occurring in the nature. This kurtosis value can be calculated using this formula. Kurtosis is equal to mu 4 upon sigma to the power 4, where mu 4 is the fourth central moment and sigma is the standard deviation of the distribution. Sigma can be calculated from the variance. There are 4 different type of kurtosis depending on the how distribution compares to a normal distribution, which has kurtosis equal to 3. Excess kurtosis is the difference between kurtosis of a distribution and 3, and it can be positive kurtosis, it can be negative kurtosis or zero kurtosis. Also these all positive, negative and zero kurtosis, they are again divided in 3 types: mesocortic, platycortic and leptocortic. Mesocortic is means that distribution has a moderate or medium tailed shape similar to a normal distribution. The excess kurtosis in this case is approximately equal to 0. Polycortic means the distribution has a thin tailed or flat topped shape, meaning it has fewer or less extreme outliers than the normal distribution. The excess kurtosis here is negative. Third one is leptocortic. Leptocortic, this means the distribution has flat tailed and peak shape. This means it has more extreme outliers than the normal distributions, and the excess kurtosis here is positive. This is the code for measuring the statistical parameters. You can go through this in my GitHub repository available at www.github.com/drAtul/image filters. If you go there, you can get this code and you can explore, you can understand how statistical parameters of the image has been measured. Another statistical parameter can be for the color images. This can be the mean value of red, green and blue 3 planes, and as we have discussed this already in the means. So instead of taking mean of every, you can take the mean of RGB plane, then again you will get a mean value. From that also you can take a mean of rows and mean of columns and overall mean of the image. Here I have shown that how the average value of an RGB plane is calculated. For the first pixel there was 3 values, and when these 3 was added and divided by 3, then value coming out as 69. And we can do the Python coding for calculating these all, we calculating the matrix features for the image one by one. So we have to take one standard or blank image as zeros, and then we have to go and take the 2 loops, one for number of rows, one for columns, then go inside, then take the first value of the image by taking the index 0, and then from the second plane first value taking the index as 1, from the third plane of the image taking the index as 2, and then at last you can see the features. You need to convert it into a single line to be considered as a feature of the image, and then you can use the reshape command. For reshape command we have to have the knowledge of number of rows and number of columns. In the MATLAB Colab you can see the number of rows and number of columns and how many number of pixels are coming out as a feature. You can see it is in lakhs for the color image. Next thing, you can also have the features from the edges of the images. Edge detection techniques I have discussed in the previous session about the filters that is used for edge detection. The results obtained from these filters can be used as a feature. Do you remember the names of the filters that are used for edge detection? Pause the video and pick up pen and paper, write your answers in the paper, then you can continue this video. Edge detection features or edges in features are the corners where the pixel change drastically, so we can edge can be stored in an array, so that we can visualize the edges by using the gradient, but manually you cannot do. You can write the functions for gradient also by using the operators, and the scikit image library of the Python provides the functions for edge detection, so you can use that also. Now you can verify that 3 kind of filters are used for the image edge detection, mostly, that is Prevet filter, Sobel filter and Canny algorithm that I had discussed in the last session. You can use the result coming out from the edge detection technique as a feature. The image extracted after edge detection can be used as a feature of that image, that is different from the original image. Now in transform domain is very useful for signal processing, image processing and video processing. In transform domain, the basic transformation is Fourier transform, which started with by the Fourier with Fourier series, and then nowadays it is converted, or many new transforms have been evolved, that is discrete cosine transform, DCT, discrete wavelet transform, DWT, and multi-level wavelet transform, multi-DWT, and then Hopf transform and many more transforms. Transform domain, there is some advantage, that is why so many advancements are coming into the picture in this transform domain. The transform domain coefficient with truncation or compressed image features. If you are applying deep learning in your research work, then features are not required, but if you means what is done, if you do not need the features, but from where features will come. Actually the training will not be done without using features. For training purpose you need the features, whatever the learning method may be, machine learning or deep learning or whatever kind of learning is that. So in deep learning what happens, actually there are many thousands of images are there. So from these thousands of images they take all the data as a feature and do the classification, clustering, and then after clustering, if they see that there are some features which are very efficient or which prominent so the feature selection is done and the selected features are then processed further for that purpose, and these selected features are processed and from that deep learning is performed. So in this way deep learning is very useful. And so where were the features? Features are automatically calculated by the deep learning. Features are not given externally to the deep learning. Sometimes features are given to the deep learning trained model for classification purpose. That is a different issue and I will discuss in later on. Okay, great. So we have reached here and we have understood a lot of image feature extraction methods in detail, and for also I have considered the features here for the pixel values, for the RGB values, and for the statistical features I have discussed mean values, median, skewness, kurtosis, and many other important statistical parameters. You can explore more statistical methods, many more measures of features using statistical things to do the feature extraction process. I hope this video will be useful for you, will be informative to you. And about the codes, I have already told that it is available in the GitHub repository. You can reach to the repository using www.github.com/dratul/image-features. All the codes that I have discussed, also some theories related to the discussion, are available in this repository of the image filters. Thank you all. Happy coding. Meet you again in the next tutorial.